Hello everyone, good morning. I hope you're having a great Monday. So today I want to talk to you about something I've been seeing a lot on Instagram, and that is that there are 75 Leetcode questions, which if you know all 75 questions, then it's likely that you'll succeed in a top FANG interview or some other kind of interview. So I decided that maybe it would be beneficial if we look through some of these problems and maybe work on them together. So if you just Google 75 blind 75 on Leetcode, this is the post that you'll see. You can see there's different categories, and so today I'm going to choose a string category because I think that might be the easiest place to start. And one thing that I think is interesting is looking at palindromes. And so I'm going to choose this valid palindrome problem to work through today. But again, if you'd like to see any other problems, go ahead and comment them below. So the first thing is to read the problem statement. So a phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forwards and backwards. So alphanumeric characters mean that they're actually a letter, not a comma or a colon or a space or anything else. So let's take a look at this first example. We see that the input is a man, a plan, a canal, Panama. So is this a palindrome? Well, we need to look and see if the first character and the last character are the same. So A and A, M and M, so on and so forth. My name, Anna, is actually a much simpler palindrome because it's A and an A. But this longer string here is also a palindrome. So you can see that once we remove all the spaces, then the algorithm should check to see if there is actually a palindrome and then return true if so. So let's get started on the solution. The first thing I'm going to do is just kind of define the algorithm. So the first step in the algorithm is going to be to take all of these characters and remove the strings and make sure that they're all lowercase. Remove the strings, remove the non-alphanumeric characters, and make sure they're all lowercase. So first, we need to do some string parsing. The second step then is going to be to check to ensure that the characters are mirrors of each other. So if there's an A in the first place, there should be an A in the last place, so on and so forth. So the second thing would be to see if the letters match. We'll just say that. See if letters match. Then return true if so, false if not. So again, the first thing to do is going to be the string parsing. So there are a lot of very simple one-line ways to do this in Python. If you know of any of those ways, I suggest you pause the video now and comment what you think would be the best way to do this string parsing, or go ahead and open up a terminal and try it yourself. But I'm going to do kind of a longer version in case we have some beginners watching. So I'll declare a variable called newString, and that's just an empty list. Then I will say, one thing I guess I forgot to say is a string in Python, this data structure here, S string, you can think of as just an array of characters. So we can iterate through the string, and then each time we hit a case where we want to remove that, we'll just not append that value to the new string, and if it's a character, we will append it. So let's say for letter in S, the string that we're passed in, if the letter is not equal to a space, so we want to remove all the spaces, and the letter, now this is kind of a funky Python function that is part of the standard library, so is lnum is true. So if it's not a space, and if it's an alphanumeric character, that's basically what this function call is doing. Then colon, because we're entering into the if statement. We want to append the new string with the lowercase version of the letter. So letter.lower. And just to make sure that we have the correct string, let's go ahead and print new string. We could go ahead and return true, assuming we've found a palindrome. We'll go ahead and return false within the algorithm, but let's just make sure we got our new string correct. So in case one where the string is actually a palindrome, because we're default value returning true, it said we passed the test case. But here's our string. So we've done the parsing correctly. So we can go ahead and remove this print statement because we know we parsed it correctly, and we've done step 1 of the algorithm. Now the second step is to see if the letters in the string actually correspond or they match. And the string is actually a palindrome. So again, I'm going to use a 2-pointer approach. So with this string here, I'm basically going to have a pointer here and a pointer here, and if those characters are identical, then you can keep moving through the algorithm. You can look at the next value and look to see if those characters are identical, so on and so forth. If they're not, like in, well, there's not really a great example of that, but if they're not, like if the string is hello, then the left pointer would be on the H and the right pointer would be on the O, and H and O are not the same character, so it would return false. So when you find the cases that they're not the same character, go ahead and return false, but if the pointers point to the same character, then return true. So to do this 2-pointer approach, we need to declare a left pointer, and that's going to start at the 0th index of the string, and then we're going to have a right pointer, and that's going to start at the rightmost character in the string. So length of the new string and -1 because we start the left at 0. Now let's use a while loop because we want to say while the left pointer is still on the left side of the string and while the right pointer is still on the right side of the string, and then ultimately they'll meet in the middle. So we'll say while the left index is less than the right index, again colon because we want to enter into the body of the function, if our new string that we've created at the left index equals the new string at the right index. So we're in the case where the two values are the same. There's an A and an A. We want to increase the left pointer 1 because we found the same index, so left plus equals 1, and we want to decrease the right pointer 1, so right minus equals 1. So now we're shifting the pointers, we're bringing them one in, one closer together to look at the next two values. Otherwise, if they're not equivalent, if the left index does not equal the character at the right index, that's where we're going to return false. So if this part of the algorithm succeeds, then we'll hit the default return statement, which is return true, but if there's a case where they don't match, we're going to go ahead and return false. So let's run this code and see if it gives us the expected output. So we passed the first test case. The second test case was false because of this EA thing they have going on. And the third case, just a space, is true. So let's submit and see if we pass all the test cases that Leetcode has. And we did. It didn't do super great with memory, so I bet that there's better ways that we can do this. String parsing, again, I would encourage you to comment if you know a better way below. But thanks for tuning in today. If you have any Leetcode questions you want me to solve, go ahead and comment them below. Otherwise, we'll just keep working through the list of 75 blind questions. So have a good day, y'all.